Look at one. Let's go through one like this together. Oh, not that one. We just did that one. Like that. Okay, so scrutinize that a little bit. What do you see? Cross out the x's. Okay. So one thing we could do is we could just leave these two equations as is. And the x's will go, right? Okay, so then if we add those up, we get negative 5y plus 5z equals 11. Okay? Now what? Which other two should we probably combine? The equation, like rows, we're talking about equation 1, 2, or 3. Which other two could we? 1 and 2 we could do. Okay, so what's your suggestion? Then multiply equation 2 by 2. Okay. Okay, we add all those up. Yeah. Oh, yeah. You're right. Thank you. Yes. Good catch. Thank you. Whoops. There we go. And the x's cancel, and I get negative 10y plus 10z equals 24. Okay? And now we can create a 2 by 2 system. So if we push both of those together into a 2 by 2 system, we get negative 5y plus 5z equals 11 and negative 10y plus 10z equals 24. Now what? Negative 2, right? Okay. That makes sense. Yeah, okay, so you're looking ahead a little bit. Good. So that's going to give us positive 10y minus 10z equals negative 22 and negative 10y plus 10z equals 24. Well, look, if I add all those up, look what happens. The y's cancel and the z's cancel, leaving me with what on the left? 0. So I get 0 equals 2. What's that telling us? No solution. Yeah. Okay. Okay, good. That worked. That's not how I would have done that one, though. Does anybody see a way it worked? Does anybody see a little bit more efficient way of doing that one? Just stare at those. Do you see something right away? And you'll kind of get used to looking for these patterns. Do you see two of them that we could combine right away and be done with this? Not have to do so much work? 1 and 3. Everybody see that? Look at 1 and 3. You can see right away that 1 and 3, that they are multiplying 3 by -2 is going to make all of the variables cancel. Everybody see that? That the ratio of the coefficients in 1 to 3, it's always 2, right? The coefficients are always twice as big in 1 as they are in 3, right? And so by doing that, look how much quicker that's going to be. If we just keep this one the same, we multiply this guy by -2. We get it in one step. Okay. So can you kind of internalize that and think, as you're looking at problems like this, you always want to take a second before you jump into these things and really like think about your strategy. Can I see that kind of a relationship where the I'm going to be able to cancel multiple variables by just multiplying through by a constant, right? Where the coefficients are all proportional like that. Okay. Okay. Whoops. Solving a dependent system. Okay, so what about this guy? Scrutinize this one a little bit. What am I going to do here? Second and third. Okay, if we look at the second and third, what's going to happen there? If we look at the second and third, they're going to cross each other out, aren't they? Yeah. So if we multiply through by, leave this one the same, right? And we multiply this guy by 2. We're going to get negative 2x plus 4y plus z equals -2. And so if I add all those up, I just get 0 equals 0. Everybody see that? Okay. And it works that way for any of the two that I combine, doesn't it? Yep. Yeah, you could do 1 and 3, or you could do 1 and 2 for that matter. Everybody see that? They're all going to give you the same result, aren't they? Right? Like if I multiplied this one through by 3, again, I'm just going to get 0 equals 0 no matter which two I pick on this one. So what's that tell you if we just get 0 equals 0? Okay, infinite solutions. And so this is where things get a little bit tricky because there are multiple ways. Remember yesterday, there were multiple ways we could get infinite solutions. Like what were the ways? Think about the ways that 3 planes intersect. What are the different ways we could get infinite solutions? There's 2 ways. Okay, they could all be the same plane. Or they could all intersect on a line. Right. Okay, which one do you think's going on here? They're all the same plane. Yeah. Now, why is that the case? Well, because if this were a line, if they intersected in a line, we couldn't be this dismissive of specific solutions. I mean, this isn't telling us anything about the solution set. All it's saying is that it's all reals, right? That anything you do here, any values you choose for X, Y, and Z are going to work. They're going to make all this system consistent, right? No matter what values I pick, I'm always going to get true statements from all 3 of those equations. Okay, does that make sense? Okay, so this is one where, well, I shouldn't say that. I have to refine that. What I just said is not true. I can't just randomly pick a value, an ordered triple, and expect that it's going to work in all 3, right? Because it has to be an ordered triple that sits on that plane, for example. All the planes are the same plane, but it has to be an ordered triple that's a solution of that plane. Everybody get that? Because I can't just, like a plane, like if we're talking about a plane in space, there are an infinite number of points on that plane, but there are also an infinite number of points in space that are not on that plane, right? We'd have to pick examples of order triples that actually satisfy one of these equations. And if they do, they satisfy all three. Everybody get that? Okay, so then what's that telling us? It's telling us that these are all the same planes, right? They're the same planes because any solution that works in the first one is guaranteed to work in the second two, right? The other thing that gives this away is the fact that the coefficients are all proportional to each other, right? You can see that these are just different expressions of the same plane. By multiplying the second one by -3, it's the same as the first one, right? By multiplying the third one by 6, it's the same as the first one. So this is the type of infinite solution where they're the same plane. Now let's look at one that's not that way. Okay, let's look at one like, do I have this on a... Okay, let's try this one, I guess. I just can't remember what I did here. I think this is the one I wanted to do. Let's try this one. So you guys tell me, what should I do here? Which variable should I eliminate? Perfect, top 1 by 4, because I've already got the second equation in terms of x and y, right? So I want to collapse this to a 2 by 2 system by eliminating z from the other equations also, right? So then we could just do this. We could go, I'm just going to scoot this whole thing over here. We only need to go one direction on this one. So multiply this guy by 4, and I get 12x minus 16y plus 4z equals 0. Leave this one alone. Oh, okay, this is a board work one. Yeah, no wonder. Okay, I don't want to do this one. I wanted to save this one for you guys. You got a good start on it. So let's actually do this one. I just need to make this bigger. And let's put, I'm just going to put it on its own page. Yeah, now I remember. Now I remember what I was doing. Okay, so look at this one. Tell me what to do. Okay, so first and third, that's a good idea. So multiply third one by 5. And that's going to give us negative 5x minus 5y plus 20z equals 20. And then we just leave this guy alone, right? Okay, if I add those up, what happens? No solution. Oh, that's not what I wanted. That's not what I ordered. What's going on here? First one. Yeah, okay, I get no solution. That's not what I wanted to do. I picked the wrong problem. So what's the answer to this one? I mean, no solution, right? What's that tell us? If when I look at the first equation, which represents a plane, so call that plane 1, third equation, call that plane 3, when I combine those, if I get no solution, what's that telling you about those two planes? Yeah, they're parallel, right? Now there may be other planes that aren't parallel. Like for example, if I took equations 2 and 3, yeah, if I take equations 2 and 3 and I multiply this guy by 2, Okay, what's happening there? So, whoops, I didn't. What I didn't actually multiply, did I? Negative 2x minus 2y minus 8z equals 8. And what do I get? When I add those up, the x's cancel. I get. Yeah, you're right. Positive 8. Yep. So minus y plus 7z equals 18. Okay, so things didn't cancel there, right? Okay, what's that tell you about the intersection of those two planes? Yeah, they intersect. What's that the equation of? Negative y plus 7z equals 18. What's that look like? What is it? It's a line. Yeah, it's a line in the yz plane, isn't it? Right? Everybody agree that that's just a line in standard form in the yz plane. You guys are used to knowing or graphing lines in the xy plane. If this were in the xy plane, it might have looked something like negative x plus 7y equals 18, right? Everybody get that? Like if I solve for y here, what would I get? I get y equals 7z minus 18. So in the yz plane, let's say that here's my yz plane. We'll call that the z-axis and that the y-axis. What would the graph of that line look like? Have a y-intercept of negative 18 and a slope of 7. Yeah, it's just a line, right? Okay, so they intersect in a line, but these two are parallel, so therefore you can't have any solutions to the system, right? Okay, unfortunately, that's not what I wanted to do, though. I wanted to do one. Hopefully, I've got one in here. Yeah, this guy. This is the one I wanted to do. I think. Oh, did we do that one? Yeah. Well, that's not it either. That's not it. Oh man, I got to grab one. I don't think I put one in there, but I want to go through one other kind. There's a really interesting kind here. Okay, give me a second here. Man, I thought for sure that would have been it. Okay, I got to check this one real quick. I want to just see, make sure we didn't make some dumb mistake. Oops. Okay. So what happened here? 2, 1, negative 1. Oh, never mind. No, that's right. That one was no, we said that was no solution, right? Yeah, that's right. So I just picked a bad problem. I didn't pick the right problem. Let me grab a better problem. Okay, so help me out with this one. What are we going to do? Which variable do we want to eliminate? Top and third one by 3. Good idea. Okay, so if we do that, I guess I can scoot this guy over. I could, yeah. I could multiply this one through by 1/3. So that's going to give us, and leave this one the same. No, we haven't done this one. Okay, what's that give me? Everybody take a look, please. You got to really focus here. I need you back. You got to really back in here. This is, you got to interpret this as you go. So what happens? Okay, everything cancels. We get 0 equals 0, right? Okay, so what's that tell us? Okay, maybe, right? But is the system necessarily infinite solutions? We don't know that yet. What we know about those two planes is those two planes are coincident. They're the same plane, right? Okay, but the third plane, is the third plane the same as those two? No, it's not, right? So this one cannot be the same type of problem that we got earlier. We got one like this right here, right? Where no matter which combinations of equations we picked, we always got 0 equals 0, which meant that all three planes were the same plane, right? So that's an infinite number of solutions in the form of all the solutions of any one of those planes because they're the same, okay? This one's a little different. This one, two of the planes are coincident, but clearly the other one is not. So what's this picture going to look like then? What do you guys predict the solution set's going to look like? Okay, so what's the solution set going to look like? It's infinite, but in the form of what? A line, yeah, right? So this is going to be a line of intersection. Everybody get that? Because really what it is just the intersection of these two are the same plane. So when any two different planes intersect, they always have to intersect in a line. There's no other way for them to do it. Just like anytime two lines intersect that are different lines, right? If they're not the same line, they always intersect at what? Two different lines always intersect in a plane. If they're both in the same plane, always intersect. Well, I mean, maybe not 0. It could be 0, 0, but they always intersect at what kind of place? A point, right? Two lines with different slopes, therefore different lines, always intersect at a point, right? If they're not parallel, then they're not the same line. Same thing is true for planes. If I have two different planes, right, that aren't parallel, then they have to intersect at a line. And clearly these two are different planes that are not parallel, right? So now what do we need to do? Okay, second one by negative 3. Okay, and that way we could eliminate the x's, right? Okay, so let's do that. So we're going to take this guy. Let me copy him. Okay, so we'll take this one by negative 3. This one will leave the same. Okay, if we add those up, the x's cancel, and we get the equation, what, negative 9y plus z equals 0, right? Okay, now what? Second and third ones. Okay, so what happens if we use the second and third ones now? What are we going to multiply stuff by? Okay, if I use the second and third, okay, I got a little. I guess I'm talking here that I don't think is related to this, right? So it's got to be related to this right now. You're not going to get this. Yeah, I got good stuff going on. You two contribute. What were you saying? By 2. This one by 2? Which one by 2? Now look, in the first example, we combined 1 and 3, and they're the same plane, right? Okay, so now we combined 1 and 2, and we eliminated x. Okay, so we're just going to experiment with this a little bit. You guys make a suggestion, and we'll just see what happens. Second and third. Okay, so what do you suggest we multiply by here? By 9. Okay, so let's try that. What if we multiply the second one by 9? What's the question? Okay. So if we multiply this guy by, what did we say, by 9? And we're going to leave this guy the same. Okay, so that's going to give us 9x plus 9y equals 0, and negative 9x plus 18y minus 3z equals 0, right? Okay. So if we add those up, we get 27y minus 3z equals 0. But if I divide everything by 9 there, don't I just get that equation? Okay, so if I divide everything by 3, this is going to give me same as that, right? Okay, so what did this one serve to do? Well, this one related y's to z's. This one did the same thing. Now, what if we had taken the bottom two equations and instead of eliminating x again, we were going to save something for tomorrow, and then we'll see what happens, okay?